Hello, hello. How are you guys doing? So, I'm gonna try to pick up whatever we're doing here on the channel. So, yeah, I figured we'd go for a couple of hours and maybe hang out a bit here. Uh, do some stuff on the game. Let's see. Yeah, so so we did some game state manipulation and some updating of our game object thingies here during the last episode. Let me just um yeah, so I can't really remember what we should do here. Um but I think we wanted to do some highlighting and some movement system. So let's try to get some work done in terms of that. Or maybe there we go. Um, yeah. So right now we update the transform. We could easily do the color, but anyway, I think we would like something like object picking here. Yeah, let's port some of the code for object picking. So we can pull the ImGUI mouse. And we probably need the flag. 0 is the left mouse button. So if we click, we do some mouse picking. Uh, Maybe and ask ImGUI hover. And we're not over a window. We will print clicking the game screen. Okay, let's try this. Okay, so this is not working. Let's see. Let's see. Any window. There we go. So now we click the game screen. Nothing should happen here. Okay. Just change the track here. So yeah, so we shouldn't get any console message if we click here, but as soon as we kind of like exit the actual window itself, we do get a message. So that's great. Since we only want to do this whenever we click the screen trying to grab an object. So okay, and this returns a bool, doesn't say anything about. Okay, so ImGUI mouse position. ImGUI Vic. Oh, it's not in a namespace, I guess. Mouse position. And let's print it to this screen. X mouse position.x. Whoops. Y mouse position.y. Okay. Yeah, great stuff. So we have our X and Y coordinates for the mouse position. And we will calculate we will get some information from our camera. Let's see. Let's jump into the class itself here. So we store it in a float 4x4 aligned, and we have the option of getting a reference. Okay. Let's see the camera controller. Does it allow us to get the camera? Yeah. Okay, so we can ask our camera controller to get the camera and then get the let's see the projection matrix. And we would like to store a there we go. And we want the same thing for the view matrix. We store the references here temporarily. We find the find the basically we want to calculate a array. So we want to specify our array x and y, and we kind of like want to transform from our 2D screen space into normalized device coordinates into something that has an x and y coordinate in terms of the object space, or rather world space. So let's see, let's do a normalized device coordinate here for the x component, where we multiply the mouse position dot x divided by our screen width minus 1. Do we actually have the application width here? Nah, we don't have that right now. Game state, units, application flags. Well, I'm pretty sure it's predefined. Yeah, let's start out by grabbing that. Yeah, right now it's not dynamic, but whatever. And we get the Y component here. And plus this. And then we use the hello buddy. Why am I using ImGUI? Why not? And let's see, let's get the x in world space by dividing the normalized device coordinate by the first component of the. Why should I use GDI? I don't think it makes much of a difference. ImGUI has backend integration with DirectX, so. And the first part of the matrix. And then we want to calculate the y from the projection matrix second row and second component. Let's see, does this, how is the numbering itself? The numbering itself is okay. Yeah. Okay, let's get some information in terms of where I clicked in, where the array origin is supposed to be in world space. test world space. Okay, let's see what stuff we get. Okay, so this should be something like very close to the origin, I think. Can't remember. Anyway, let's see, maybe this is not. Uh, I'm not sure this is entirely correct. Oh, wait a minute. We of course need to multiply it by the inverse view matrix. Okay. Okay, let's do a DirectX vector ray origin and do a XM vector ray direction. Oh wait, it's not the actual origin then. We need to infer that from the inverse view matrix. So let's see. Uh, inverted view matrix equals DirectX inverse matrix inverse DirectX determinant. Let's see, view mat vectorized. Okay. Let's see the view matrix here. Let's see. There we go. And then we transform the origin and the um, direction. Directx matrix multiply. Whoops, this is not it. And we pass in the origin and the inverse view matrix. Yeah. So this will only be translated by the actual camera position, and this will be transformed entirely. Let's see. Okay, let's do something like ray origin dot the first register, and then the second register, and then the last register. Test direction. There we go. Whoops, I got requires an L value. Okay, so this doesn't work. Let's see, an XM vector determinant. Okay, so let's see. The I'm pretty sure that is supposed to be negative, right? And this is supposed to be... Is this the origin? No, this is the... I don't know exactly. Maybe we want some debugging utility to actually make us draw the array itself. To verify wherever. This is the... Huh. I'm pretty sure this is supposed to be flipped. Let's see. yeah, now that's flipped. I mean, we're going along the x-axis here. I think this is correct. I mean, our camera is pretty close to the world space origin. We're still at the um, zeroed out x value. Our y is a bit above. And the z direction here is actually less than the z coordinate, meaning that the ray is pointing in the negative direction, isn't it? Or if we created a ray from the origin of the ray through the direction, yeah, it would be negative. Yeah. And we should normalize it. Directx vector normalize. There we go. Now it's a true direction vector. So we're clicking straight ahead. We're mostly going in the direction of the z-axis. Here we have more loading on the y. Here we should have more x. I can't compare really, but somewhat more on the x, I guess. And a negative x, yeah, okay. Then we want some collision stuff. Let's see. Collisions. We want to check whether our cast ray here intersects with an AABB. So let's create some stuff for that. Let's create a class so we both get a header and a CPP file. Although, maybe we just want the CPP file. Let's see. Maybe we just want to call it race. Maybe we just want that for now. And let's do a CPP file here. Include core. Maybe collisions. Let me see. Race. Oh, whoops. That's what we usually do, right? Core. Let's do something like that. Okay. We want something that takes a, first of all, we need to include the DirectX math library. And then we want something like something like uh, something like an algorithm that kind of like returns. Um, uh, do I want to be able to pass in a series of ABBs? I think it would be better to handle it in the same method. But then we need something like this. Resource types, I guess. Uh, Maybe I could just pre-declare it. And then maybe this won't compile, but let's see. Okay, so array get closest intersect ABB XM vector array origin array direction, and then a series of const vectors of bounding ABBs, bounding volumes. Okay, and then closest distance is equal to the float maximum value here, and the int index equals. Oh yeah, that's why we want unsigned and int. So -1 can be whatever we if we didn't find anything. Bounding volumes, that size, I++. So we're going to iterate. Let's return the index here. And let's do a let's just do maybe we do a thing here because we want to store a we want to store be able to store the points for the generalized method that we use. So it's basically a check on where a ray intersects a AABB at which point, and um, how much Well, maybe we don't want to do that. Maybe we maybe we don't want to do that. Okay, let's do another method here, which is called bool ray intersect AABB distanced. So and then a float reference distance. And let's do a direct, let's see, using Directx. Okay. Minimum is equal to the vector 3 subtract between the volume is it resources? I think it is volume. Oh, wait a minute. It's because it thinks it's on that side. There we go. Load flow 3. Let's see, xm vector center equals, and then half widths. And then we subtract the center and then the half widths and vector add. Center and the half widths, yeah. let's set the distance to 0. And let's see, max distance equals float max, yeah. Let me just swap the track for something more nice. Okay. And then we're gonna do the intersection algorithm, which is from the collision detection book. So we're gonna iterate over each of the axes. Let's do I think this is it. Apps. So if whatever axis in the if we're not really pointing in any direction, we want to check whether that is within the origin is within the minimum of the bounding volume for that axis. Or rather, if it's outside of that minimum, larger than, or rather, no, if it's inside, yeah. Or if that axis is greater than the maximum here. It's an early out. Because if that vector is not pointing very much in that particular axis direction, and the ray origin itself is not larger than the minimum, or not smaller than the maximum, it can't be inside the box for that particular plane, and that's an early out. We do the epsilon check because for a normalized vector we might get a very, very small number on the actual axis. So we're gonna pre-compute the the divider. Since we're gonna reuse that multiple times, float t2, compare it to the maximum. If t1 is greater than t2, we swap t1 and t2. If t1 is larger than the distance here, we set our distance to t1. If t2 is smaller than our max distance, we set our max distance here to t2. If the distance is larger than or equal to the max distance here, we return false. Okay, so this is our intersection query, and I think if we run through all of the tests, we should return true, because then our array will intersect this AABB. So now we can query if our array does intersect whoops, array direction, and let's see, bounding volumes with the index of whatever. Nah, it's because it's const. If I change it to const, yeah, we should change it to const. Actually, that's true, because we're not gonna change it. And then pass in our distance reference here. And we're just going to continue if it doesn't intersect. If the distance recorded here is lower than the closest distance, we set the closest distance to distance and the index to I. All right, so we have our intersection testing here. We have our array. So not testing, checking. So we should be able to check through a series of bounding volumes to check whether we actually collide. Okay, so let's try that. So right now our renderer here actually contains the information. I'm unsure whether it's supposed to do that, but At least now it does. So let's do a series, rather get bounding volumes. And we will simply return the ABBs here. And we will use that to check. Okay, so hello. I'm sorry, buddy. Don't have the time to check Discord right now. So we can grab our bounding volumes. And we can actually do our collision checking here. I don't think we use the red-black trees right now. Do we? No. Sure thing, buddy. We've done them here on the channel before as well. Okay, so let's do something like core collisions. Get closest intersection of the ray origin, ray direction, and then pass in our vector here of elements, and then yeah, thank you, but when I'm not asking for help, I don't need it, but thank you. Okay, let's try checking, passing out whether we actually intersect with something. Wanted to, or clicked on volume, and then the index. And if it's -1, we will know that it didn't actually hit anything. Okay. Okay, we do have a bug somewhere. Yeah, subscript out of range. Let's see. Let's step through it. So, okay, 66. So when does this actually? Sure thing. Thanks for checking in, buddy. Nice to see you. Okay, for some reason. How do we end up in a situation where. Let's just try that again. Whoops. And 14, 33, 52. Okay, let's see. We're at. Oh, wait a minute. I immediately see it. There we go. Okay. Yeah, so this doesn't work at all. For some reason, it thinks that we clicked on volume 0. Hmm. And maybe I've made a mistake here. Maybe I've made a mistake here. Okay, let's step into this function here. Okay, so the minimum and the maximum. The center is at the origin for this one. Huh. Yeah, I think that's fine. So that's for the first tile. So the ray origin is on the positive C. Yeah, I think It's supposed to have a negative C component. Yeah. So that's the problem. Maybe we need to flip one of the axes here. Let's just do that for now. Yeah, we definitely need to flip the C component itself. But not that it matters what I call it, but there was a spelling error. Let's see. Let's try inverting the Y. No. The C component is not negative. This is negative as it should be, I think. No, maybe. Okay, if I flip the camera here, whoops. Yeah, the C direction is... Yeah. There's a bug somewhere. Let's try... Yeah, but this direction here should be negative C. Hmm. So... Huh. Maybe I simply just want to set the thing here to its own negative. So now we do have array that gets I mean this should be okay, the Y component is all messed up, I think. Let's see. I mean, the Y component shouldn't be negative. Uh, the Y component shouldn't be negative, maybe. No, the Y component is still off. Um, yeah, in general, this is not. It's like maybe I just want to negate it. Simply, let's try negating it all. Hello and welcome. So now the Y is positive, the X is positive, which I think suits everything. The X shouldn't be positive now. Uh, how I code? I'm sorry, I'm not really sure what you mean by that. How I know what to do? I don't know. I read about stuff and yeah, how other people do it. I don't know if that's an answer. Let's see. My old code. My old code may have some because I was using a coordinate system That was a bit funky as far as I remember, so there might be some problems here. But yeah, how I translate from the window space into world space might be what's going wrong here. Let's see. Let's see. Oh, wait a minute. When we rotate the camera, we're actually in view space, aren't we? I'm unsure whether... And this, for some reason, the C component is always pretty big. And right here it gets close to 0. No, it gets close to a half. That's not correct. There's something wrong with this algorithm, but do I normalize it? Yeah, I do. Redirection 0, 1, 2. And it's the redirection like that. And I don't store the wrong ones, right? View matrix, yeah. So this should be all right, right? Huh. I mean, let's dump the origin as well. So the origin is correct. We clicked almost entirely at the center of the screen. And if we do like this, we do have a vector that has a small step upwards on the y-axis. But I think this is not correct because right now the camera is kind of like in the middle of the screen, and if we were to cast a ray, cast a ray from the middle of this down to here, we should expect a negative y value. I mean, the x is probably right, right? I'm not sure. I'm not sure. It's not very large. I mean, if I click here, the primary component should be the x. It's like the c even, at least they should be kind of like shared here. It's like the c even gets larger by just moving the camera here. Well, that's not supposed to affect it. If I move past the origin, then the c gets negative. Okay. I don't know if... Huh. Now only the y component seems off. Yeah, that's definitely some stuff related to the view matrix itself and the I mean, the view matrix itself is correct, but this computation here is not. It's definitely not. Mm. Uh, so we're in view space from screen space to NDC space to View space. Let me just try printing this. Is this actually in world space? Let me see. Let me see. Let me see. Well, now the X and Y seems to be behaving correctly. Yeah. Yeah, we should get. Yeah. Yeah. Since our X is wider than the Y, we can get a bigger range. Hello. So this actually translates into world space. Maybe we want to. Maybe we don't want to transform. Yeah, so the problem is that the direction into the space itself here. What I'm trying to say is that these coordinates here are actually related to, whoops, actually related to our camera position and in terms of the world space. So the X here should be 0, close to 0, right? This should be positive, this should be negative, this should be, yeah. So relative to the camera, that actually makes sense. So the origin is negative on the x-axis, positive on the y. This should be close to 0 y. The c should be let's see here. Yeah, just to I mean the c component is off here. I think, isn't it? Maybe it's not. Yeah, I'm standing pretty close to the origin here. This should be something like the origin. Yeah, we're pretty close. Yeah, that's pretty close to the origin itself. So this direction here Pointing at the negative C? No, that should be 0. I'm not clicking at the... maybe in view space I am. Maybe in view space I am. Okay. What will happen if we do like this? Okay, the C will always be 1. This actually makes sense. Yeah, so this is in view space. But the transformation from view space into world space is kind of not working correctly. Um, maybe I want to negate that transform matrix. Let's see. XM matrix. Let's do something like that. So now the no, that's definitely not it. I need to go through the math, don't I? Yeah, I think I need to go through the math because uh, yeah. This is not supposed to be negative. Uh, uh, yeah, so the math is somewhat off here. If I move the camera here to the origin and click, yeah, I need to go through the math, I think. So now, okay. Actually, when the camera itself is at the origin, everything except the C component seems correct, right? I mean, when I click down here, the Y component here is negative. The maybe I need to subtract the specific direction with the origin of the camera itself. Huh. I mean, when so everything is kind of like flipped here. So this is supposed to be the negative C, which it registers, and this is supposed to be up, and this is supposed to be down, which it does recognize. This is supposed to be positive X, and this is supposed to be negative X. Okay, yeah, so as long as our origin here is close to the real origin, our direction does get correctly changed. But I mean, so our camera origin here, okay, let's try subtracting it. Let's just do a test vector here. Let's subtract the ray origin here with the ray direction ray origin, and let's dump it to the console. And let's see if that makes more sense. So I'm clicking here. Well, the Y component is pretty messed up here. Doesn't make any sense. The C component is now correct, but and the X component is somewhat correct, but the Y itself is just messed up. Maybe I want to do it before I transform it. No. No. Let me think here. So what could be going wrong? Okay, I can actually do this transform normal here. And I can do something like this. Did I? Oh, there we go. Does this change anything? Is it my math calls that are bad? This looks a bit more right? Let's see. Up, down. Yeah, this looks better. Definitely better. Yeah, maybe the math calls themselves were just bad. -1. And if I rotate it, yeah, okay, it changes. Okay. That was the mistake. Bad math calls, I guess. So the test direction, there we go. Yeah, everything looks better now. -1. Clicking on that. Let's see. '64. 0. Yeah, it's definitely not working as intended because I'm pretty sure it's not supposed to be that way. Okay. 32 -1. 48, 48, 48. Okay. So our origin is probably correct. Maybe I do want to. Well, why isn't it normalized? Let me look up this method here. Okay, so we actually need the XM vector normalize here, I think. Maybe like this. And what does our console tell us? 64 minus 1. Yeah, probably something in regards to our checking algorithm, because now the ray direction itself is actually correct. I mean here, yeah, the ray direction itself is correct now, and we have our correct origin in terms of our camera. Yeah, so these data points here are not our problem anymore. Everything seems to be working. So the next problem is probably our intersection algorithm. Um, Yeah, so this is basically because I don't know the DirectX math library good enough. This just rotates and scales, but doesn't uh, transpose, or rather translate the vector itself. And this only translates the vector. So yeah, we zeroed out the last component of the vector, but it ended up being transformed by the old other math calls, so that was the problem in terms of calculating the vector. Well, at least now I know why that happened. It's good to know that we can transform whatever we need to transform by using those specific math calls. But so if we step into our algorithm here, we do have a problem in terms of calculating the intersections, I think. Let's see, we grab the center and the half widths here. Let's see. We iterate over the axis for each one. Let's see. Is this method wrong? I'm not sure. I'm not sure. I'm not sure. I'm not sure. -1. Well, that's definitely not true. Will it ever find anything? if I move close. Yeah, bounding volume. (24) for some reason. Bounding volume 8, this should be 0. Yeah, 0. Okay, so it does find something. Bounding volume 0. Well, I have to disagree on that. Bounding volume 0. Let's see. So whenever we render it, I'm pretty sure we actually we use the sender itself. Ah. Oh, wait a minute. Maybe we actually need to transform the well, let me just do something. It's gonna be really, really, really so slow. And definitely not something that we want long term, but I want to dump the center here. Center. Okay. Just for good measure, let's see. So we check for each of our objects here. 0, C4, 2, 0, 0, 0. Yeah, so we are checking in world space. Let's see. We are checking in world space. Clicked on volume 40. And I have 64. Actually do have 66 volumes because I have 64 chess squares and 2 pawns. -1. So if I ever get close, -1, 64. No, 64 can't be it. So maybe our algorithm here is messing up instead. Maybe that's it. Okay. Okay, let me just step through it and see if we actually do get a hit. So I'm gonna proc this and I'm gonna intentionally click on the first bounding volume. Here we go. So the bounding volumes here, the first one should be the one that we clicked on. So do we intersect? No. No, we don't. Okay, there's a problem somewhere. There's a problem somewhere. Let's see. There's a problem somewhere because let's just step into this the first time it gets called. Because right here, whoops, uh, let me just see. So I'm clicking that one. Our bounding volumes here, it has the world space coordinates here of 0, 0, 0 and the appropriate values here. So let's see, the ray direction is primarily negative. And the origin is floating up in the sky, a bit offset right there. Okay, so we step into this function here. So the center 0, 0, 0 works fine. The half widths get loaded fine. The minimum gets loaded fine. The maximum also gets loaded fine. All right, that passes for the x-axis. That passes. Okay, something happened for the y-axis. Something happened for the y-axis. Yeah. Let's see, did I make a mistake somewhere? Oh! Do you see it? Do you see it? Do you see it? I need to type in a T here. Oh my god. A freaking missing T. Now that's rough. That's rough. Okay, now hopefully everything works. Clicked on volume 1. Yeah, everything works. Oh my god. So no problems with the actual algorithms, only with typos and calling the wrong math functions. Okay. Well, uh, yeah, well, okay. That's just what happens. 64, 65. Here we go. Here we go. Here we go. Here we go. Everything works just. Uh, Let's see, everything works fine, except that we get several calls to this function and I don't like it, so inside our camera controller here. Well, let's see, is mouse clicked, and let's see. Can we get any repeat flags? None. Uh, let's see, repeat. Let's try setting that to false and see if we only get one rock. Yeah. Great stuff. Okay. So now we have our, let's see if I understand the ImGUI library. No, it doesn't matter. Anyway, we now have mouse picking, which is great. Okay. So now we can grab whatever AABB that we kind of like click on. Let's see, when we create the bounding volumes themselves, maybe we want to assign a, let's see, load mesh, create object, create drawable mesh here. Let's set the AABB center. We could couple the objects. But since we know they mirror every drawable mesh, we would automatically know the index for the underlying mesh itself. So we could do something like create an interface here on the renderer. Let's just do something like static void mark mesh, select mesh, constant signed int index. Okay, doesn't want to do that. Let's see which order update mesh transform here. Okay. So we could do something like if index larger than or equals 0, we set our M instance drawable meshes index 30 to true. And let's see, selected just for now. Okay. And then inside our renderer, whenever we create the debug information here. Draw debug. Let's see. Color. Draw ball. Selected. We create it with the red color. Debug information if it's selected. Otherwise we I can't do that. Let's see. Mm. There we go. So this should still create them with green, yes. But if we try asking our renderer here, select mesh. Okay. Well, it was supposed to change something then. And of course set the maybe we would want something like an old index to swap it out, because right now we will simply mark them forever, which is fine, but yeah. Okay, we can store the uint 32t selected index uint previous selected index. Let's see, this is supposed to be an int because it might be invalid. Also, this is also supposed to be like that. Okay. Okay. previous index. Let's see. If the previous index then is larger than or equal to 0, false. Okay. Inside our application here, we set our, let's see, game state selected index. And we pass in our previous index here. There we go. Okay. So now we simply are able to select the objects and the okay, great stuff. So now we can actually click objects. Great. And we can actually see what we have selected. All right. Just in time for me to end the stream since I gotta get some dinner and yeah, we now have mouse picking, which is pretty great. So yeah, during the next episode we are now able to click our objects, so we will be messing around with actually kind of like maybe moving some objects uh, by clicking on them, or either the object itself again. Yeah, so we could do something like, for instance, inside the movement system here, we could do something like click object, enable movement, then click space in on chessboard, move to that piece, place. Yeah. Yeah, we should try doing something like that, so we can click the Paul here and move him, for instance, to that position. So when we click him like that, when we click this square here, Paul should move. Yeah. But that's it for this episode here. Uh, yeah, I made a lot of stupid bugs during the typing of the code, but it got sorted in the end. If you enjoyed this or found any of it helpful, entertaining, or just soothing, that if you're having trouble, you're definitely not alone, then feel free to comment, like, or subscribe. Hopefully, I'll be seeing you around the channel in the future. And thanks for tuning in. All right, bye bye. Take care.